Okay, so practice test number 17 says we want to find dy dx for this, so we have to do the derivative of this problem. So the derivative of 2x is 2. The derivative of y squared will be 2y dy dx. You know what? I'm going to write y prime because I got quite a few to do here. That means the same as dy dx. And then I got to do product rule here. So first term is negative x times the second term, times the derivative of the second term is y prime, plus the second term, which is y, times the derivative of x, which is 1, and that whole thing equals 0. So what we're going to do now is we're going to get the y primes. They're already on the same side. The y primes are on the same side. So now I'm going to get all the parts that don't have a y to the other side. So I'm going to subtract 2 and subtract y. And over here, I'm going to factor out the y prime. Now, you could leave the negative out front and put parentheses and have y, the negative of y plus 2, but you don't have to. And then I'm going to divide by that thing in the parentheses over here. Now, this could be your answer, but you could take a negative out of the top and bottom and make this x plus 2 and take a negative out of here, which would flip-flop their signs. So if this is a multiple choice question, you could have either one of these two answers. And again, they could have put negative y plus 2 in parentheses on this one and put 2y minus x. So see, if I take a negative out of the bottom one, the negatives would give you a positive, and then you'd have to flip-flop those two. All right, so that's part A. Part B says, write the equation of a tangent line when x equals 1. So we've done this a lot this year. To get the equation of a tangent line, I need a point and I need the slope. Okay, so first of all, I want to find the point that goes with this. Okay, so I want to find the point that goes when x is 1. So I got to come up here to this equation and plug 1 in. So when I do, I'm going to get 2. 2 times 1 is 2, plus y squared minus 1y equals 4. So I have a quadratic, so I have to get this equal to 0, and I'm going to put it in descending order. So when I subtract 4 over, 2 minus 4 gives me negative 2 equals 0. So now I have to factor this thing, and I'm going to get y minus 2 and y plus 1. And so from that, I get that there are two different y values. There's y equals 2, and there's y equals negative 1. So I have 2 points where this is true. So my ordered pairs, my points are going to be 1, 2, and 1, negative 1. So I actually have 2 answers for this one, 2 places where this works. So now I need to find the slope at both of these places. So I'm going to go y prime, and then I'm going to use the point 1, 2 to get the slope that goes with this. So I'm going to use this one over here on the right. I'm going to use this one because I don't have to worry about as many negative stuff. So I'm going to use that one I highlighted. Could use any of them. So I'm going to get 1 plus 2 over 1 minus 4. When I plug that 2 in down there, 2 times 2 is 4. So I get 3 over negative 3, and I get negative 1. So one of my equations is going to be y minus 2, I'm using this point right here, is going to equal negative 1 times x minus 1. Now that is one tangent line. There's a second one because there's another point 1, negative 1 works. So I'm going to use 1, negative 1 and plug into this thing. So I want y prime for the point 1, negative 1. And again, I'm using it up here, so I'm going to get 1 plus 2 all over 1 plus 2 again. So this is going to be positive 1. So using this point with that slope, I'm going to get y plus 1 is going to equal, now you can put the 1 there or not, you don't have to, x minus 1. So there are actually 2 tangent lines. There are 2 tangent lines at x equals 1. So that's kind of a tricky problem. Going on to part C. Part C says, find the coordinates of each point on this curve where the tangent line is vertical. So if tangent line is vertical, it means the line's going up and down. That means we're looking where the slope is undefined. Vertical lines have undefined slopes. So I need to find the derivative of this because that will be my slope. And then I got to find where it's that derivative is undefined. So is this the same one we just did? Let me go up there and look. If it is, it'll be nice. I hope so. Okay, I'm going to look and see if that's a square. Okay, everything's the same except the 3. So when you do the derivative, you get 0 over here anyway. So this is the same derivative. So doing the same steps, I will get that y prime, the derivative, is equal to x plus 2 over x minus 2y. Okay, so you can work through that again. The only difference was that 3 there. So now I need to find where the slope is undefined. So I hope you realize slopes are undefined when you have 0 in the denominator. So we need to say x minus 2y has to equal 0. Let me check this out again. Find the coordinates of each point on this curve. Okay, so we need to find where this equals 0. So I guess I would solve this for, I don't really like this problem very well. So I would add 2y over. So it looks like to me, everywhere where x equals 2y is going to be true. This will be true wherever x equals 2y. So this is kind of a tricky problem. So what I need to do is I need to plug this 2y in for x up here and then solve. So we're going to see what happens here. So I get 2 times 2y plus y squared minus 2y, because again, I'm plugging 2y in for that x, times y. So I'm going to go ahead and make that squared. And that's going to equal 3. So I need to solve this thing. So let's see, I got 4y minus y squared equals 3. So I'm going to get this equal to 0. I'm going to add y squared over because I want a positive y squared. Subtract 4y and then get plus 3. So it looks like to me this is going to be true. This will be 0 whenever y equals 3 or y equals 1. So now I got to plug both these back in here to find the x value of that. So x equals 2 times 3 will give me x equals 6. And then x is going to equal 2 times 1, which will give me x equals 2. So I take 2, 1. So at the point 2, 1 and at the point 6, 3, the tangent line has a vertical slope, or is vertical. I should say the tangent line is vertical. So kind of tough problem with a lot of algebra in it. So that's all of 17. Problem number 18 we're going to go do. Or was that 18? No, that was 17. Problem 18. Okay, here's problem 18 right here. And there's 3 parts to it as well. I got to look at it with my glasses because I can't see that top very well. Let's see, first thing we're going to do is find the derivative of that function. So I'm going to do that just like I did the one a second ago. We got implicit differentiation. Okay, so we're going to do implicit differentiation. So I'm going to get 2x plus, now I got to do product rule here. First, derivative of the second, plus the second, derivative of the first is 1, so it's just y, plus the derivative of y squared would be 2y, y prime, and the derivative of 1 is 0. So again, I gotta get my y primes on the same side, which they already are, and I'm gonna take these 2 over. So this is very similar to the one we did on the other page. And then I gotta divide by this x plus 2y, and those reduce. Divide by x plus 2y. So there's that answer. And again, you could write this and left the negative out front and done this. Either way is okay. So either one of these two is fine. Then it says find all points on the curve where the line is parallel where the tangent line is parallel to this. Well, from this, we know the slope of this line is -2, which means we want to find where this derivative equals -2. So we have to take, and we got to, because the slope, this is the slope of all the tangent lines right here. So I'm going to take and put this slope equal to that -2. Oops, that's minus y. Okay, and then I need to multiply that over. So I'm going to get -2x minus y is going to equal -2. And I'm going to go ahead and distribute this to both these. That'd be -2x minus 4y. Now I'm going to combine like terms. I hope we see these x's cancel. So that's, I'm going to add this 4 over, and that's going to give me 3y equals 0. So it's going to happen where y equals 0. That's the only place. So now I need to find the x value from up here back to this original point when y is 0. So I'm going to plug zeros in here and here. So when I plug zeros in there and there, I'm going to get x squared plus 0 equals 1, and I square root it. So x will be positive -1. So there are 2 points. 1, 0, that's positive 1 in that 0, and -1 in 0. So at those 2 points, so you should say at this point and this point, the tangent line has a slope equal to -2. And we're going to do this last problem here. Find all x values on the curve where the tangent line is horizontal. Well, horizontal lines mean the slope equals 0. So once again, I'm going to take this slope and I'm going to set it equal to 0. Now this just says find all x values, okay? So we don't have to find points. These others said points. So I'm going to take this again and I'm going to set it equal to 0. Now I have told you before that you can just take the top part and put it equal to 0, okay? You can do that. So wherever and the reason is because if I put this on the bottom, the first thing you're going to do is multiply that over there and get 0, which makes this go away anyway. So you just have to use the numerator. So we are looking for anywhere where y is going to equal -2x. So wherever y equals -2x is what we're looking for again. So I'm going to take -2x and I'm going to plug it back up in here to the y's. So when I do that, I'm going to get x squared plus, I'm going to go ahead and take x times -2x. So that's going to be -2x squared. And then plus y squared. Well, that means I got to square -2x. So that's going to be plus 4x squared. And I want to find where that equals 1. So I combine like terms. Let's see, 4 and 1 is 5, and 5 minus 2 gives me 3x squared. So x squared is going to equal 1/3, and this one's kind of ugly. So at x equals positive and negative square root of 1/3. So we're talking like right in here somewhere on both sides. Okay. So there's going to be 4 answers if you look at this, because there should be up here, down here, here, and up there. So there should be 4 answers. So I've got to plug these 2 things. Actually, there's only 2. So I got to plug these x values back in up here to find the, oh, we don't have to do that. We only need the x values, right? So good. We don't have to find a point. If I needed to find a point, I'd have to plug that back up here into this original equation, but it only said x values, so I'm actually done here. So at x equals those 2 values, the tangent line is horizontal. Okay, so you're going to try 24 on your own. That's great. So I want to know, does anybody else text me, or I'm sorry, not text me, chat me if you want to see any others. If you got any of those others you had earlier you want to see, let me know. And just so you guys know, I've got the answer to these problems on this key. Now, I did number 25, and I think his answer for 25D is not right. I actually asked him why he didn't take into consideration any of the negatives, but here's this week's chart. this week's homework. There's Monday stuff. There's a bunch of videos on here. But what I want to show you is right down here on Thursday, there's the Unit 3 practice test key. I put the key in there for you. And then I also put the key for the stations. Here's the solution for the stations up here on Wednesday. So you can go in there and look at those. Okay. And then Monday, you can come in and ask more questions on Monday. If you're cohort 2, you're going to come to 4th period Zoom, you can ask me then. Do you guys have any more questions you want to go over? And again, if you look at this, thing up here, some kids earlier asked me, these are the other 2 classes I've done. So I've done Big 10 E and F here and practice test number 9, Big 10 C and practice test 25 C and D. You look up here, here's practice test 15, all of it. Up here's practice test 7 and 25 A, B, and this one. Practice test 2, 5, and 21. It's here. So if you have stuff that you're not sure about, there's a bunch of them up here. Okay? Oh, wait a minute. Can you do 15 and 19 on the practice test? Okay, I've already done 15. So if you look right down here on Thursday over on the right, there's all of 15 done right there. So watch that. And then if you don't get it, you let me know. So let's look at 19. I have not done 19 yet, so I'm going to do 19 for you. Okay, let's find. There's 19 down here at the bottom. So we're going to do this number 19. It says, given that f of 4 is 6, f prime of 4 is 7, f of 6 is 10, and f prime of 6 is -5, we want to find the derivative of the inverse. Derivative of the inverse. Well, the derivative of the inverse, I'm going to use method 3 because that's my favorite. Method 2, you might be able to figure it out from method 2, but I'm not sure. So this is the formula. This is the formula to find the derivative of the inverse right there. So what I need to do now is I want the derivative of the inverse when x is 10. So I need to stick a 10 in here, and I need to stick a 10 in here. I hope you all know that if xy is a point on f, then a point on the inverse of f is going to be y and x. So basically, see this y is this value 10 right here. So what I want to do is I want to find what gave me a y value of 10. So if you look right here, that's a y value of 10 for f of x right there. So that means this is 6, 10, which tells me the inverse is 10, 6. So that allows me to know that because that 10's right there, that allows me to know this is that 6 right there. So this means I need to find the, oops, I left my 1 off, sorry. So I got 1 over f prime of 6 because of this. So I come up here and look at f prime of 6, that's -5. So this is going to be a -1/5 or 1 over -5. That's the answer. Anybody else got anything you want to see? Oh, somebody said 17. I just did 17 today, man. So you can go, I'm going to post this video. You can go back and watch it. 17 was the first one I did on here. Does anybody else have anything you want to see? Again, no test Monday. It's going to be Tuesday for cohort 2. Wednesday for cohort 1. There's nothing Thursday. Friday, we're going to Zoom again so you can ask more questions. And then on Monday, cohort 1 is going to finish the test. And Tuesday, cohort 2 is going to finish the test. And we're going to start doing unit 4. So I think we're done unless I see another question come up. Anybody? Okay. then I'm going to sign off. I hope you guys have a great weekend. Do what's right, not what's popular. And I will see you guys on Monday and Tuesday next week.